yourself style points, if not precision points.
True.
Vaulting into the bed.
Yeah.
Not recommended.
Mike, how much does an Alvin plate weigh?
That's a great question. I don't know the answer. I really should. One weighs twice the other one.
What?
I mean, that is the correct answer.
I'd say they are 10 and 20 pounds.
Okay.
That's what I think. We usually go in with a single plate and a double plate, and I can't reach either of them right now, which is also a problem.
Not very helpful, huh?
We're okay, we're making 15 meters per minute, but it has been duly noted in our logbook that that is unacceptable.
15 sounds like a screaming speed for the way up.
Yeah.
Some of those
pretty
guys
good.
come 13.
Do 15 with the Diffendale maneuver.
What is that? A little
apply some lateral thrust, and it pushes the thruster wash off the starboard bio box, which usually is a big restrictor to us pushing up, because all the flow coming out of the underside of the thruster hits that box, and it just diffuses every which way. So if you throw the lateral thruster on it, it moves it off the box and into the open water. And
Trademark.
you go faster.
That's a trick that sounds like it came from years of experience.
Yeah, well, he's got them.
Oh, so cool. I love this. I love the creative ways that people follow along with us. One of those ways is checking out our Nautilus Live bingo cards. You can print your own bingo cards and listen along for some of the most popular phrases that come up either in the midwater or exploring on the seafloor. But we've also had people drawing along with us and tweeting that art. And someone just wrote in that they are crocheting along with us and creating deep sea creatures and of some of our discoveries. I also have a crocheting pattern that was designed by one of our SCFs based on like the patterns of the waves, and she designed this whole crochet blanket pattern. So, no, Tammy, I know you're very crafty. Maybe that's your next project.
Not quite that.
Not that crafty. Not that flavor of
Somehow
crafty.
I could see Tammy doing that up there while, managing all the video controls.
Doing it all.
Like I have a full blanket by the end of watch.
I have on other vessels knit or crocheted while on watch, but there's a little bit more going on here than some other vessels.
I'm envisioning a quilt full of sea stars.
Yeah, today's.
Yeah, that's today's quilt for sure.
Today's quilt.
We can have a quilt of the day pattern.
One sablefish, one star.
One 30 rack, 30 head.
I do crochet those little animals and stuff. Right now I'm making dinosaurs. But I found a jellyfish pattern that I'm very excited to make little jellyfish to give to a friend who is pregnant right now.
Fantastic.
Sounded cool.
Yes.
Why do you think we didn't find any hydrate?
I don't know. Maybe we didn't look in the right places. Seems like there was patches where maybe just dissociated, right?
Yeah.
In the
And maybe
hydrate
it's
found
just
out.
under the surface now. Like maybe there's sediment covering what is there. We know it should be there. What do you think?
Yeah, I think you're right. I think the exposed hydrate, you gotta have those depressions. Maybe you get like little wall collapses on the sides that expose the hydrate, and you need to be lucky to be down here after a kind of a fresh hydrate exposure occurs. And we kind of missed out on that this time with it's all covered.
The hydrate found us for a little bit. Is it
Yeah.
like encrusted on the Herc a bit?
So we know it's there. It just wasn't visible.
Yeah. It's pretty impressive what the seeps can do. Well, seeps, dissociating hydrate possibly, with altering the seafloor. A very powerful mechanism for seafloor alteration, making the big mounds, or the crater rims, the depressions.
Now, how quickly do you think that shape forms? Is it, sort of bubbles and small, starts as a small collapse and slowly goes in, or you imagine that, it looks, some people have written in that it looks like a bomb crater or something, like a bunch of methane goes at once and you end up with a pockmark. Do we know anything about
What? I'll take one from Mike. That's a great question.
that?
I don't know, but we've been to this site 3 times now and have had imagery over it. So there's a data set there available to kind of see how things change over the course from 2016 to 2019 to 2021.
Mm-hmm.
I think there's room probably for both mechanisms, and I think one of the interesting things would be to figure out the signature that's left behind by something sudden and, something sudden versus something that's a little more subtle, like slow outgassing or slow release of a methane reserve. But I would guess that they would leave different like morphologies on the seafloor.
We've seen in studies looking at imaging the subsurface at pockmarks that they can be really long-lived, but they'll go through phases of dissociation and pockmark creation, and then they'll fill. You'll get sedimentation over it. It'll smooth the seafloor, and then you'll have another episode of kind of collapse. So you'll see these stacks of pockmarks just on top of each other.
We all kind of made it, Nicole, Bob. Yeah. Well, oh yeah. The last one, I did the 5th one back, and it blew out everywhere. There's no hole in that quiver, I bet. Sin was a good one.
Oh.
It is possible, but that's a strange thing to do. I'm sure it's there. It's just buried.
Anson, are you on SPL? Are you muted? You can hear. Do you want to introduce yourself? Do you want to introduce yourself? Sure. I don't know where the mute button is on that one.
'23.
Blowing pretty hard. Yeah.
What's that? Oh yeah, yeah. Yeah, that can get, actually that's kind of like some, but we don't have a lot of swell out there yet. So
Yeah.
that can get kind of difficult to look at. It can get much worse than that.
Winds first, swell.
Yes.
Awesome. So guest in the control van. Hi, Anson.
Hi everybody, I'm Anson. I'm a scientist working on the gas type bottles, and I'm just here to watch you. This is my first time being up in the control room, so it's really interesting for me to see all the work that you're doing.
Welcome.
So Anson receives the gas tight bottles, waiting patiently for Hercules to get back on deck.
And then what do you do?
So after we recover the gas type bottles, we have a high vacuum system that we connect them to, where we extract the gas and subsample it so that it can be given to the different laboratories. The laboratory that I'm working with, we study the helium 3 to 4 ratio. It goes to other laboratories as well.
What does the helium 3 to 4 ratio help us learn?
Well, the helium 3 to 4 ratio gives you an indication of how connected the system is to the Earth's mantle, because the crust of the Earth is enriched in helium-4 because of radioisotopes that produce alpha particles, whereas the mantle of the Earth has fewer radiogenic materials, and so you you get a higher helium-3 to helium-4 ratio. So if we see a enrichment in helium-4, it tells us that the gas is possibly crust sourced. But if we see instead a greater amount of helium-3, then that means that there's likely some connectivity to the mantle. And helium-3 is a primordial isotope from stellar nucleogenesis.
Awesome. Does subsample just mean divided up?
Yeah, we divide it up into 6 different samples so that it can go to the helium lab, then it can go to other labs as well. And at this time, I can't fill you in on the other labs. I'm not real privy to who else looks at it.
So
How many?
I guess the helium-3-4 ratio work is, that really complements not just looking at the hydrocarbons. That's kind of the, Nicole was asking earlier, we were talking about what other things you look at with these seeps is that they're conduits that give you insight into the deep earth. So seeing helium-3, helium-4 ratios indicative of the mantle is very exciting to think that you could have fluid interacting with mantle rocks, percolating all the way up through the crust into the sediment section and ultimately here onto the surface. That's what these seeps are, a window into that process, which is really cool.
Do you want to explain a little bit how, I think depending on, the age of our viewers, maybe they've been learning Earth systems recently. Maybe it's a little bit in the Wayback Machine for them, but a lot of times, you see these models that have these very tidy, kind of candy coating is the crust, it's the Earth, and then you cut it away, and like each of the layers are very distinct.
Yes.
But it sounds like we're talking about the mantle, but we're here looking at the surface. What are those interactions like? How are those things actually getting up there? It's probably more complicated than the candy coating Earth.
Well, the Earth is divided into several layers: the inner core, which is solid; the outer core, which is liquid; the mantle, which makes up the bulk of the Earth, which is technically a solid, but it does flow over millions of years. And then the crust is very superficial. So continental crust is somewhere in the order of 70 kilometers thick, but that can vary. And then oceanic crust is much thinner, like on the order of 6 kilometers. But oceanic crust it's chemically different from continental crust. Oceanic crust is chemically derived from the Earth's mantle. And when we take water that comes from that, then we would expect to see a higher helium-3 to helium-4 ratio, because one of the properties of oceanic crust is that it does tend to have a lower radioisotope concentration. There's fewer alpha particle producing elements in the ocean crust, but the continent is different. Even the sediment, like what we just saw earlier, it doesn't look like much, but it came from the Earth's continent, and it does have an enrichment in thorium and potassium and uranium. And so each one of these things produce alpha particles, and they produce helium-4 specifically. So the helium produced from this region, superficial helium, that comes from like a superficial seep site, we would expect to have a high helium-4 to helium-3 ratio. If we see a high helium-3 to 4 ratio, then that means that there's deeper connection, and there's the Coquille site that has been visited in the past, and we're hoping to visit that in the future. And that location, it's gas that's coming up through continental sediments but it has a high 3 to 4 ratio, a high helium-3 to 4 ratio. So right now it's a puzzle. Like, it seems like there's connectivity there to Earth's mantle. Like there's very deep fractures or very, very deep faults. but at this point, for me, it's an unsolved puzzle.
If the methane comes up from the mantle and then has to travel through like a long path of sediment, do you get isotopic changes in that? Can it be altered along the way, or is it pretty clearly locked with kind of its origin story?
Well, as far as helium goes, like you said methane. I'm not real privy to methane chemistry, but with helium, it is a noble gas, so it tends to not react. It either gets trapped by things or it goes free, like a helium balloon, like a birthday balloon that's made out of mylar. It'll trap helium because of the molecular structure of that metallized balloon. But if you just have a little rubber balloon full of helium, they get smaller, and that's because helium goes right through the pore spaces of the rubber. And it's like that in the ocean. There's certain situations that trap helium on the molecular level, and there's other situations that don't. And it's complex.
So after you subsample, are you doing any of that analysis on board the ship, or do you take it back with you?
The mass spectrometer that we use to find the helium 3-to-4 ratio is not here on this ship. It's back in the laboratory at Hatfield Marine Science Center. So it's a very custom mass spectrometer. It's made specially for helium 3 and helium 4. So you can't use it to measure a whole lot of other atomic masses, just helium 3 and helium 4. And it's a lengthy process. It takes days for each sample. That's how it feels anyway. Maybe it's a little bit quicker than days, but it's
a pretty big instrument too.
It's very picturesque, yeah.
Yeah, you wouldn't want to take it on a boat.
Like what kind of size are we talking?
It's maybe the size of a really big old school microwave. Wait a minute. Well, the whole laboratory is the size of this control room. The mass spectrometer itself is, maybe the size, a little bit bigger than a microwave, like a really big microwave, but cooler looking.
Cooler. Awesome. So we're potentially setting up with, a couple months of analysis work to do?
Yes.
Navier Bridge. Roger, will do. Okay, roger. When we're hitting 300.
Yeah, you can start moving them at 300 or now if you want, whatever you would prefer.
So hitting 300, what are you feeling our recovery time is going to be from here?
Computer says 20 minutes to surface, so
okay.
30 minutes on deck. So well, you can just tell her 20 to surface is
okay.
Fine for her.
Do you think they need me out there?
Bridge nav. We're at 325 meters and roughly 20 minutes to surface.
So how many people work on these samples? Are these primarily your samples, Anson, or are there like more people in the lab?
So we take 6 cuts from each gas tight bottle. So each bottle will give us 6 samples, one of which I will measure in the helium laboratory, and the others it's an extended, they go to an extended group within the Earth-Ocean interaction group, and I'm not sure specifically. Like I can guess what they measure, but I don't know. So I think I can get you a better answer and tell you later.
Solid. That sounds great. pass that answer on when we know it. Shannon, how about you? How many days, weeks, months of work are we queuing you up for with the samples you're taking?
Probably a few months, because we'll not only extract the stuff in the lab, which only takes, you can usually do 24 to 48 samples a day. And that process usually takes 2 days, but then in the end, we'll send all this stuff out to sequence, and that can take months waiting for it. We have several, trips, sampling trips this summer. This is just one, so they're all kind of ending around the same time. So September, we will get a lot of samples back, and one of my main responsibilities will be extracting the DNA from all of them.
0.3
Okay.
at current heading.
Yep.
Lots of work ahead in the lab, but I'm excited for that.
Moving at 0.3 knots on our current heading.
How many samples do you expect you'll leave the ship with?
Roger, thanks.
So eDNA wise, filters, I'll have about 130, because for every Niskin bottle, I run 2 liters through a filter, so 1 liter per each filter. So if we go on 11 dives and have 6 Niskins, and then times that by 2, and then I'm also hoping to get some microplankton samples, and I have some organismal sampling. So a sizable amount, but then we also have another trip going out that is more CTD based versus ROV, and those units can have 24 Niskins, and so they'll have a lot more samples coming back on that trip. But we obviously with ROV can get a lot closer to the seeps and kind of be able to characterize the environment. So even though I don't come off with as many samples, these samples are very important to understanding the ecosystem down there.
All right, Jeff, we're going to talk us through what is happening right now from your seat at 270 meters.
Yes, we're ascending. We're at 267 meters right now. There's a number of people on the back deck getting ready for recovery. We're coordinating with the bridge on the vessel's heading and speed. And it's going to be the intricate dance of recovering Argus and Hercules here in the next 20, 30 minutes. And I'm playing intermediary between the different groups on the vessel in this navigator role.
Yeah, a new feature for our Nautilus viewers, we've patched in some of the sound of the radio into SPL, into our audio line. So you have a bit more of a complete picture of what it looks and sounds like as we're recovering the vehicles. Mike, what are you setting up for from your seat?
So I'm doing it a little bit early here, but for recovery, we just want to make sure that we're not, all the boxes are in as full as they can be. So if you just saw me poking around there, I'm just looking to make sure things that I can secure are secured, make sure the arms are in a stowed position. And then that's about it until we get to the surface. In daylight, we make sure all the lights are off when we're on the surface. But that's about it. The camera has a retract and extend function, so we want to make sure that that's fully retracted. That's about it. And then Rendy has a similar little list of things to go through.
What's on your list, Rendy?
So for me, I gotta maintain the delta depth between Argus and Herc on a level plane, because we don't want to drag each other when going up on the water column. And also, well, once we we're at 50 meters. I can turn off the lights. I can make the tilt for the Herc camera you see on Argus be sort of level. And after that, I can turn that motor off. And yeah, I guess that's pretty much it.
Solid. If you have questions for the team, get them in. We'll answer questions for, it's like, this isn't a unit of time, it's a unit of distance, about 130 more meters. And then we'll step back off the questions and just let you listen into the recovery. So send them in on Nautilus Live. If you're watching over on YouTube, hop over to the website and drop a question in there. Tammy, what does your recovery look like? You're doing a masterful job of DJing Channel 3, by the way.
I just have to check all cameras. We have several deck cameras as well as some safety cameras and cameras, or a camera that watches the wire for Argus. So we have to make sure the pilots have all their cameras as well as all of our deck cameras. And we have to make sure we can, essentially, we say talk to them, control them. So everything is network based. And so I have to make sure I'm able to follow the ROVs back onto deck so the pilots can see what's going on, and also for safety of the people on deck. And as the vehicles come on deck, I will stop the recordings because we record all cameras on the ROVs as well as the main cameras that you guys are seeing on the feed 1 and 2, or the quad 1 and 2. So stop those and check everything as well as monitoring all the audio and everything that goes out live to you guys, and then making sure everything's wrapped up so you still are seeing something at the end and it's not just black screens in your quads.
Getting some cool shout outs that it's fun to watch us still have the sun up as people are in different times around the world watching in. Gosh, here we go. Here's the list. We've got folks watching in the United States, Canada, the UK, New Zealand, Turkey, Sweden, Mexico, Israel, Denmark, Germany, Australia, and Bonaire. I want to go on a dive trip to Bonaire. Let's visit you.
Bonaire's awesome.
I don't know what's more impressive, us diving on Astoria Canyon at 850 meters water depth, or the number of countries watching us dive.
It's awesome,
Yeah,
right?
it's an impressive list.
It's a good one. So yeah, good morning, good afternoon, night, wherever you are. Our plan is to dive again at 8 a.m. So in about 14 hours, 13 and a half hours from now, to be back in the water then. So Anson, how long will it take to subsample the gases? Like, what is that, you know? What's your next few hours look like?
So I'm going to have a busy night. We're going to recover these gas tight bottles. I'm going to take them into the lab, clean them, and each one is probably going to take 2 to 3 hours to extract the gas from.
Wow.
So when are we going to recover these at? Maybe we'll get these on deck at 6:30 or 7. Is that about right?
Yeah, about 7.
Yeah, so I'll be up Probably till 2 or so. And I was hoping really to get a hydrate sample because it'd be really exciting, but I was preparing myself for a 3 to 4 a.m. night. It looks like it'll just be 2 in the morning, but it takes 2 to 3 hours to subsample each one of these gas tight bottles. And we put the gas inside of a special glass. It's the glass molecule, the silica tetrahedron. This special glass that has an aluminum atom inside each one. And what that does is that keeps helium from escaping. Because if we put helium inside a just typical glass jar that's just made of silica only, the helium will escape through the glass, literally. So we put it in this special glass, and that's important here because I don't have to really make the mass spectrometer measurement now. We could put it inside the special glass, and then we can leave it on the shelf for months, and I can measure it later.
Are the containers fragile?
Yes, they're like little test tubes.
Okay.
Yes, if you drop them, they might not break.
You want the launch recover salvo?
Yeah, you can go
Or
there
they
now
might.
if you like. Yeah.
Don't test that.
Yeah. Sounds dangerous.
Yeah, each one is small, about the size of a test tube.
Okay.
Yeah, that's a good timing for Anson and I, who are sharing a cabin. Right when he's finishing, I'll be getting up at 3:30 in the morning to do the dive planning for tomorrow.
You guys are good cabin mate selection, good pairing. We try not to put people on the same watch in the same cabin so that you have, some amount of independent time in your room. But it doesn't usually work out perfectly like that. So
Well,
that's great.
These last few days, we've all been very busy. I think Anson and I have been catching sleep whenever we can, not on necessarily a exact schedule yet.
Yeah, not quite yet. Jeff, you are getting a shout out from Brandon and Jenny, who say hello.
All right.
Hi, Brandon. Hi, Jenny.
Those names are familiar. One of them could be my sister. Shout out back at her if she's listening.
It was fun. Susan's parents wrote in from Wisconsin today, which was
awesome.
very cool. Very cool.
I'm just very proud how many Wisconsinites are on board.
There's a couple of photos we need to organize. One is all the people with a Wisconsin connection. One is all the people with an Oregon State connection.
Yeah, we need a
Gotta get that team
and then
group
just
photo.
Me on the other side of the deck with a U of O.
Yeah,
Well,
then a one photo of you standing alone on the bow.
Yeah, we can get we can get a beaver picture, and then we can get an Oregon picture.
Yes.
I think I should just wear Oregon gear in the back of your beaver
Just
photo.
lurk right
Just
in the
lurk
back.
in the background.
That's an option.
I mean, I brought a ball cap.
It would be sort of like classic for all of it.
Oh yeah.
But yeah, I figured we needed to tweet at Oregon State with this many beeves on the
There's
ship.
a lot of wind, but it's all lined up. We're moving ahead at 0.3.
Tammy, Wisconsin is writing in as well. Wisconsin is online representing with you.
Yes. Woo, Wisconsin. We're everywhere.
We're everywhere.
Seriously though.
Everywhere I have ever lived, I've ran into not just one or two Wisconsinites, I've run into quite a few.
Does that say something about people wanting to leave the state?
I wasn't going to go there.
She's speechless.
I mean,
I think it means that they're great explorers and adventurers.
Okay.
Wisconsin. They take their cheese culture and must share it with others.
Share it with the world.
we must spread our cheese everywhere. I must say, though, it makes it very easy to find the Packer fans.
Yeah.
or anywhere to watch a Packer game, all the way until I was visiting Costa Rica during the playoffs, and that's all I wanted to do. And I actually stumbled upon a Wisconsin-owned Green Bay Packer, or like Packer bar. Like literally, there was more Americans in there than Costa Ricans. It was fantastic.
That's amazing. Yeah. So some questions for what's next for the week. We'll just wrap it up there and let you watch this recovery as we're approaching 50 meters. But our plan is to stay on this tempo, dive 12 hours a day, map and sample process 12 hours a day. So we'll be diving at 8 a.m. Pacific time tomorrow until 8 p.m. And we will be hopscotching our way up and down the coast. We're looking to get back down to the southern Coquille sites if we can get there with the weather conditions. Right now we're in northern Oregon, just at the Columbia River outflow, but we'll kind of keep working our way around to different sites, hopefully get down south, and eventually by the end of next week make our way back north to Port Angeles, Washington, the Strait of Juan de Fuca, where we'll end the expedition. So, you know, dives daily, come back, hang out with us. If you've missed any of the action, check out the gallery and check out some of the highlight videos that are there from previous expeditions and last year. And we'll see you at 8 a.m.
All right, 50 meters.
At the deck, no, we're all stopped. Yes, we're fine.
Bridge nav. Use secure tanks, enable air tuggers, and ask if the captain is on the bridge. Or is the captain on the bridge? Thanks.
Stand by 1 mark, we'll hold here for a minute.
Okay. Enable R to center. We're auto-centered on Argus.
Yeah, is the bridge ready?
I think I got, let me double check. Bridge nav. Are we good to begin recovery? We're good.
Yep. So you let Mark know, you talk to him. Roger, yep.
Roger, we are ready. Stand ready.
Coming up.
Randy, get your camera tilted horizontally.
I got it up. That seems good, right?
Keep going with the camera.
Keep going.
Yep. Needs to be level, right, or it'll hit the deck. That'll be good there.
This is good.
Yep. Secure the tilt motor.
Roger.
Okay.
How do you know that it's really level? That's one thing I can never find
Just
out.
have to get used to it. I mean, you can go look at it on deck if you want to get it for sure. I don't think it's quite level there, but it's fine.
Yeah, roger.
Where's Herc?
Have we lost SPL?
Bingo.
Getting a bad fix.
There we go.
Right in the middle.
Yeah.
Okay, turning off lights.
Yeah.
Turn off thrusters.
Oh, you really don't have that same prop view of the ship.
Sure, the meso turned off.
Yes, thank you. Turn off the meso sonar. Turn off all that stuff, Randy, please.
Roger.
Just leave the ground fault.
Nav bridge.
Hold on.
Bridge nav. Yeah, ship is back on DP now, holding position.
Roger, thank you. Bridge is holding position.
Roger.
Any vessel changes requested?
No, we're good here.
Roger.
They're happy.
So did I switch this to sonar dive, or that's the next thing there? Just turn them off, the beacons. Okay. Okay. Can wait till Herc's back on. They're not using this anymore. Okay. I got a second. Oh. You usually leave that running. Okay. Got it. Close this. Probably. Yeah.
All right, so Argus is back on deck, strapped down. You can see our deck chief, Mark DeRoche, there releasing the daisy chain line. It's going to pass it to Kylie. Kylie is our Olympic contender tonight in daisy chain pull. to pull that entire length of line that is wrapped in a non-binding knot around, tying together the umbilical, the tether between Argus and Hercules, and also the lift line, spectra line for the crane. So as Kylie pulls that, that separates the two lines, and you can grab the spectra line and take it over and tie it onto the crane, which will help the crane get a hold of Hercules. Once that happens, it's just a geometry problem. The crane will start pulling in, and as the crane gets a shorter line to Hercules than the tether has between Argus and Hercules, it starts pulling it towards it.
See the end of the daisy chain? No, okay. Oh, I see him. All right, see, I see that the line is taut.
Okay, we've got you on the crane hauling in if you want to try the lateral to the right. Good.